Hello friends. So in this video we are going to learn a little bit about Kubernetes. Hi, my name is Ramit and I'm going to show you a little bit on Kubernetes. So for this tutorial we are going to use Minikube, which is basically a single node cluster of Kubernetes. Right now I have stopped it. So let's just start it out. Okay, I think it has started booting up. As you can see, it's the version 1.7.0 and it will take a little bit of time. So why don't we just get around our slides up till this thing starts. This is what we start around. As you all know, Docker is a very powerful build for your Linux containers, and it helps you containerize all your applications, and it eliminates the friction between your development and production environment. So let's just jump to Kubernetes. Basically, when Kubernetes started, it was basically introduced by the Google guys, and it was, I think, launched in 2013 or 14, somewhere around. So the aim of the Google guys was quite simple, that they wanted to present an orchestration tool which they have used personally inside their own massive interior software architectures, and show it how the world they can use it. So we are just going to start and study it. As we all know, some of the features that basically Kubernetes provides is restarting, supporting of maximum applications manually or auto scaling, auto healing. That means basically if your container dies, a new container will spawn up instantly, so you don't have to worry about downtime basically. So that is one of the best features why Kubernetes is famous. Some basic terminologies like pods. So basically pods are just a space in which your containers are created and destroyed. It's a logical collection of containers, as you can see. The master is basically your central node which controls all your other nodes, and the master contains all your special features that Kubernetes provides, like auto replication, auto scaling, etc. etc. So that is what it is. Minion is a little bit specific term. Minion is a worker node that runs according to the master. So basically, let me show you something. So this is how it all looks. The master is here and the minion node is here. It has a Docker container. The pods are running, and let me just check. Yeah, it's running. The minion is running, the Docker container is running, the pods are there, the containers are there. This is a very simple diagram of how it all began in Kubernetes, and that is how it is even now. So we'll study into a little bit more detail about this, but we are not going to cover too much detail on Kubernetes. This is just the getting started part, so I'm just going to cover the basics. These are all stuff we are going to cover in the next part. So one thing that is quite common, how it all works out, it's through this kubelet. What is kubelet? It's basically an agent. So whenever you have a node on which you are basically declaring it a minion, your kubelet is one agent that runs in the background, and it has specific functions, like it is a YAML or JSON object. It could just identify from your file, like how you want to create a Docker container or how you want to spin up services. It does all that. And also, like as you can see, it has a file, it has a HTTP endpoint, it has a HTTP server. So basically what I meant to say is, this is the basic preliminary agent in the back end that helps you get started and running up. A little bit more detailed diagram of Kubernetes cluster is this one, where your kubectl, this is your client side command line tool, which is used to interact with your master, and your master contains an API server, a scheduler, a replication controller, and using this you can basically control your other two minion nodes. We can take this, for example, this is like virtual machine 1, virtual machine 2, which basically contains more and more pods and more containers. These are some stuff like kubelet, cadvice and proxy, which can be used by the Kubernetes to scale up or scale down your container instances. There are a lot of stuff in Kubernetes itself. These are just the basics. So like for example, this cadvisor, I'll tell you in the afterward what its role is like, what is proxy, what is this labels, why or how pods are running into this, and a lot of stuff. So let's just keep this rolling. Okay, let me check this thing if it is started. Alright, as you can see, we have started running the Minikube. It has run fine. So what I am going to do is basically run through the information here quickly, so that we can just get started by running our Minikube. So what etcd is? Etcd is distributed consistent key value store for shared configuration and service discovery. What it means is that suppose you have multiple hosts, right, and you want to identify, or your system wants to identify which host it should interact for which kind of service. So etcd stores all that information. All your cluster data is here. It is, as you can see, default built into Kubernetes. So this is one of the parts, and etcd is built by the core OS guys, so it is kind of pretty cool, right? Now the services part. This is something which most people confuse with or don't get with the deployment part. Now one basic simple thing that I want to share with you is that Kubernetes services are the services which are indirectly or directly seen to your front-end user or to your back-end user. So basically the idea is that your service should not go down even though your deployment goes down. These are just two parallel terms, but do not get confused between them. The deployment or the scaling up and scaling down can actually go down, there is no problem with that, but your service should not die. That is the whole fundamental on which I think the Kubernetes relies on. So it is very important that your service should not die. As you can see, if a client is interacting with a kube proxy, this kube proxy will automatically redirect it to the backend pod 1, pod 2, pod 3, depending on their application, whatever the client wants. Now this is very interesting term, the namespaces. So what happens is, suppose you have a node on which you have run all your containers or your pods, but the problem is, can you differentiate the pods into different an abstraction layer, basically into some abstraction layer, so that it is even more better and precise for the whole system to run effectively and give you maximum throughput. So this is enabled by namespace. It is basically an abstraction which is defined by a logical set of pods. Basically you can say that all the pods that you want that are contained into a namespace, right? And you have a policy even, so you can access them, and it has its own authentication for doing that, right? So this is what namespace is. A little bit more detail is when you go into the Linux kernel. Basically the namespace, C groups, SE Linux drivers, these are all the stuff that are already included in the Linux kernel. That is why I believe when Kubernetes started and the Docker container project started, it was a little bit difficult for the Windows platform to pick up Docker and other things. The reason is because this stuff is not present because obviously Linux kernel is not even present in a Windows machine. So that is the reason, I believe, why Windows users will suffer a little bit because of this whole stuff. Now, the interesting thing about etcd is that when etcd is running up and working, what is basically happening is you need a strong fabric network between one node to another and between etcd. This strong network basically helps you provide a strong I can say network between one instance to another, one node to another, one container to another, and so on. So this is provided using Flannel. It uses etcd to store network configuration, allocated subnets, and auxiliary data, right? So basically what you can do is you can transfer one piece of information from one particular, I can say, container or pod to another pod or container relying on another node. So this is pretty much fundamental and very useful while putting Kubernetes into production. So a little bit of diagram how Flannel works is basically you have your pod here, right? You have a container up and running. Now this container basically has its own IP, right? But when you see the overall pod, it has its own different IP. So you can scale up or down your container, that is fine, there is no problem with that, but your overall IP remains to be the same. And here also it is the same. So whenever you have one machine, that is your CoreOS machine or your simple virtual machine, what happens is there are two IPs and your Docker 0 this is the Docker 0 port, as you can see here. I can show you. Yeah, this is the one. So this port is basically connecting you to your outside network, right? So it connects with this, and basically it has a Flannel 0 based with subnet, which basically helps you allocate another IP to it. And as you can see, a packet can be transferred from one machine to another or from one pod to another using this. So yeah, this is pretty much when we try to explore how Flannel works. More stuff can be learned on their website, that is on GitHub, basically on GitHub page that is there, of how this whole packet is transferring, what are the limitations that they have right now, and yeah, that is pretty much it. Replication control, this is really interesting. So what happens is, now just assume that you have a nginx service that you want to run, right? And there is just this thing that you want to replicate it so that you can serve on different ends, and that is like you want it to be done with ease, right? You don't want to type in commands again and again and then recreate the same type of container from the same type of pod. That is going to be like stupid. So this is something very useful, and it is present in the master node of the Kubernetes. So basically, as you can see, it ensures that a specified number of pod replicas are running at a certain time. That is very true. If there are too many pods, then it can kill it. Okay, it has that ability, right? You can create a new pods from a template, that is absolutely fine. So you can from your YML or JSON file, you can just specify 3 or 5 or whatever the number is, and this helps you create that many number of pods using the same image. So that is pretty much it about the replication controller. This is the architecture, nothing special. Here the replication controller lie, and here you have the services, your containers, your pods, as I have already described above. Now volume is something which is another aspect of it. Like many of you might have known that Docker leaks or containers leak information. That is very, very true, right? So that is why there was a bit problem for people adopting containers in the data world. So with Kubernetes there has been some modifications along the path how you can use or mount volumes from one another, and you can use a container or pod to interact with it, right? So this is how Kubernetes support different volumes. As you can see, it has mtdir or simple host path, right? GC, persistent days, AWS Elastic Block Store, NFS, and all these types. So you can use Kubernetes to basically interact with your volumes, and your volumes would be safe because it is a kind of separate entity for Kubernetes. It is not going to just use containers to store all your volume. You can just see over here, like there is a mounted network that is provided by the Kubernetes, and you can interact with the minions and then your volume here. So it is pretty much it that is here. Of course, there has been a lot of modifications, and now I think it is much better right now. But this is how the whole fundamental idea of how Kubernetes interaction with the volumes goes. Now this is quite simple. As you all know, we need monitoring, right? Ops is all about monitoring and maintaining our services, preventing failures and all that stuff, right? So basically the idea is how you can monitor your whole container or your pods basically. So cAdvisor is just a tool, and it's an optional one, so you don't have to worry if you necessarily want to use this one or some other one. There's no such thing. And what I'm going to say is that cAdvisor is an amazing tool. I have used it personally. It is one of the first, I think foremost tools that Kubernetes launched for its support of monitoring, and it has been popular right now even. So it basically uses Kubectl to fetch all its information from, and that is pretty much it. You can aggregate all your monitoring and event data into it from the dashboard itself, and you can see how your pods and containers are running, and how your system is performing. So this is pretty good. This is a normal architecture of how or where cAdvisor is. Yeah. Label selector, this is pretty interesting. Now just imagine that you have, like just say 50 pods running, and you have 50 more containers running amongst those pods. Now one thing that is common is, like, you want to have something that could help you identify which pod is located or which pod is defined for which, right? So if you have, like, let's just say Kibana, right? You have Kibana ELK, basically that sorry, that whole app running up. So you can basically dedicate your label ELK, and you can symbolize that, okay, this ELK label identifies my pods that are different and running your ELK containers, right? You can use labels for that. What are selectors? This is quite simple. The pod, basically, here is the label, like you have labeled it. Now whenever your other service or your other pod basically interacts with wants to interact with another pod, what happens is your label selector will help you identify where the label is located, because there are 3 different labels, right? So your label selector helps you identify, or helps other services identify, where a pod is, right? So this is quite good, interesting. This is another aspect of it, like how can you secure Kubernetes. Now this is a bit older, I think, slides, so I have not mentioned it, but the secret is much more advanced right now than it was introduced earlier. So basically a secret is a set of named byte arrays, right? So all your pods, these have created a secret, okay, and so no one can just come and bypass the master node or something and interact with your pod. That is not so easy at the moment, right? I will get into the security aspect a little bit afterwards, but for now I can assure you that all your secrets or all your pods and containers are definitely very much safe in Kubernetes. So let me just show you before ending it. So we have just started our Minikube. Now let's just try to run a simple service, and before that let me show you something, right? So here you can see there is a default namespace, there is a kube-public namespace, there is a kube-system namespace. What it means is that all your Minikube that is running, or the Minikube services that are running, is basically, that is a master node that is over here situated in this namespace, right? All your default one that you're about to create on your local system will be stored here, and this, I think this we'll explore, and then you can realize what it happens, right? So let me just start again. So at the moment there are no pods, no services, nothing is running from our end, right? So let me just try to fetch or run a simple example for you guys, and we can proceed on. So in this command, before running, what I am doing is I have used kubectl, which I have configured before, and which I'm running right now. Somewhat, you can say, a default service that I'm about to run, called as nginx 1, and I'm using the image nginx and the port 80 for doing that. So let's just run it. As you can see, the deployment is created. Now when I talked about like this is kind of a service, what I meant by that, I'll just show you in 1 second. Let me just see whether this thing is created or not. Yeah, so as you can see, it has started creating, and the status shows that it has been 18 seconds since it has started it. Now what will happen is it will create this pod, and this pod has one container in it called as which is running nginx. You don't have to worry about the container, but what you are going to worry about is your pod, right? It should be up and running, and even it takes a little bit of time, I guess, to get it up and running and everything. One thing you can rely is that it won't go down that easily, like many of you might have observed while running a simple docker container, right? So that won't be the case here. It has got a lot of layers that are there to protect it from stopping again and again. So let's just wait for some while. Maybe we can show you the dashboard. Yes, maybe I can show you the dashboard. So Minikube basically provides you a simple running dashboard, which you might enjoy, because this is the same dashboard that you have on your Kubernetes. This is the one. Right now we are running version 1.7, so it is pretty cool to see some new changes and new stuff going on here. So here, as you can see, you have your deployment here called as nginx 1, your pods. This is the ID that has been generated. This is random, so this is picked by the Kubernetes system itself. There is a replica set that is there, and let me show you something. As I was talking about the kube-system part, basically what you will see right now, there is a DNS service that is running, pods that are running over here. There is a dashboard one, there is a kube DNS one, there is a manager one, and here are the replica sets and the replication controller. So this is what you do when you install the Minikube. You basically, what Minikube does is it creates a kube-system one, kube-system namespace, and basically it launches all these pods that are running over here, and you are basically running all these services using these pods. So this whole dashboard is appearing because of this running of this pod, right? So that is how the whole Minikube is made, right? Now let's just see if we have up and running the nginx, right? So it has been up and running, right? As you can see, our tick mark is there, and let's just check out some of the logs if we are able to. You can also use this create option to create your own pod over here, or application basically, and you can just do it via the UI. That is a little bit much more easier. So as you can see, here are the conditions and here are the events, how it had started up. It's pretty familiar, it's pretty easy to see, visible. You can see the logs over here, there's an option over here. So there are no messages, I guess, at the moment, but obviously when you do anything, you can just check it out whenever you feel like. So let's do something fun, and let's just try to deploy or see what our app is running, that is our nginx interface UI part, and let's just hope that we can see the port up and running, right? So let's just do that. So there are like two ways of doing this. I'm going to show you the kubectl one, but later on I will show you the another one. Right, so basically we are just exposing our deployment, that is the nginx one, and we are just labeling it as some type that this is our port, right? The 81 that we have exposed. And as you can see, we have exposed the nginx one service, which basically in simple terms means, because right now we are running on our local machine, so the thing is that it won't get an external IP attached to it, right? It will just run it in the backend, but if we want, we can just expose it to another IP, and automatically an IP will get allocated. This won't happen when you run it on some provisioned Kubernetes deployment, because what will happen is an IP will automatically get selected from there. You don't have to worry about it, right? So let me just see what the IP that has been allocated to it is. Okay, so here you can see this is the IP that has been allocated with it. Now let's just check what is happening over here, whether it's running fine, not fine, what is happening. See, this is our interface that has come. This is the nginx welcome part, and let's just see where are we with the status of the kubectl get services part. So as you can see, what is happening, there is a Kubernetes service. This is a master one that is running. There is an nginx one that has its own cluster IP. There is no external IP that's shown right here, but you can see your 80 port is forwarded to 31681, right? So that's pretty much it. And let's just see if we have any deployments. Right, as you can see, we have a nginx one deployment, and the edges is clearly shown. So yeah, guys, like that is pretty much it. I told you I'll show you another method of doing the same. Okay, let me try. So yeah, again here you have obtained the browser page of the pod that is running, and I'm just going to close it right over here. Now when we see the kube-public one that was left out, you can see over here right now the nodes would be like the single node that you are running, so it won't make much sense to see it, but later on obviously you can observe which node you are running. Here your secrets are stored, there is persistent volume, maps, this is an advanced topic, and where are we? Right, so let's just see the pods. Okay, I think this one is just made automatically. There are no pods or anything running. Right. So there, as you can see, there is no pods or anything running over here. There is certainly no deployment, nothing over here. So I think this is one left empty. So that's it. Like I guess I have for the Kubernetes part. Now we just want to bring down the whole Kubernetes setup that we have just ran. So let's just do that. It's super easy. So, okay, what I have done. Oh yes, stupid error. So here you can see their service has been created, deleted, and your deployment is also deleted. I think this is like the best way to bring down all your services, because what if you're thinking of destroying or deleting the pod, what will happen is that another pod will create in its position, and that service won't go easily down. So there won't be any point in just deleting the pod itself, right? So yeah, that is how we have bring down the nginx one part. Let's just try to check it out if we have got everything right. Yep, so as you can see, your service is gone completely. How about the deployments? Right, there is no deployments on, right? Any pods, just in case anyone is wondering? No, there are no pods, right? So quite simple, quite easy. Now let's just stop the Minikube one. So it's basically not consuming any more RAM on our machine. Another short point I like to point out with Minikube is it basically runs with your VM in its place, right? So basically, if you have KVM or you have that virtual box, right, it basically creates a machine over there by downloading an ISO image, which I think you can see. Maybe over here I ran into some errors. Yeah, I think it's gone. So basically you can see some ISO being downloaded when you are installing Minikube Start and running Minikube Start for the first time. And so that ISO is basically used to create that virtual box image, and basically what is happening is that your Minikube is interacting with that virtual box on that ISO, and then serving you the whole Kubernetes dashboard and everything. So that IP that you saw in the dashboard, I think this is the IP that belongs to your virtual machine, pretty much. If I'm not wrong, I may be wrong about this, but I think so. This is what it is, and this whole stuff is automatically running on your virtual machine. So that is how your single node Kubernetes is up and running using Minikube. So let's just forward this. For the setup, I believe this is one of the old methods. I used to do it definitely. In the first starting year or so, how Kubernetes was used is using this particular method. You have to update it, you have to install it, and then you have to build the get the binaries, build it, and then again you have to export the nodes, roles, number of minions. It's a long step, right? Now you have Minikube directly, and you can just run it, right? So these are some of the commands you can use for kubectl. As you can see, you can also just after installing, just run the kubectl. I think this would do the charm for you. So yeah, there are a lot of commands right now, and there are a lot of stuff happening over here. So you can do that. And yeah, if you are interested to contribute to the Kubernetes GitHub login, that is the Google Cloud Platform /Kubernetes, which has changed. It's Kubernetes/Kubernetes now, github.com. And I think as you know that it works on so many of these platforms, right? Obviously somewhat I designed on the questions part if anyone has. And yeah, thanks for listening. Please don't forget to subscribe, share and like the video. If you have any comments I'd like to hear, then please leave it down in the comment section. Thank you very much. Bye bye guys. Bye bye.